Today we're going to look at the sum and difference identities for sine and cosine. So what you'll see here is 4 different identities. We have the sum identity for cosine, the difference identity for cosine, the sum identity for sine, and the difference identity for sine. And these 4 identities allow us to evaluate sine and cosine functions for angles that we otherwise would not be able to find exact values for. So for example, let's find the exact value of cosine of 75 degrees. And notice 75 degrees, that's not one of our usual angles that we look at, like 30 degrees or 45 degrees. However, we can write it as the sum of 2 of our more familiar angles. Notice we can write cosine of 75 degrees. This is equivalent to cosine of 30 degrees plus 45 degrees. Or you can switch the order, doesn't matter. Either way, we can now use one of our identities from above. And notice this first one is what is going to help us, cosine of alpha plus beta. So what we're saying here is alpha is 30 degrees, beta is 45 degrees, and now we're just going to plug into the right-hand side of our identity. So what we'll get is cosine of alpha, which is 30 degrees, times cosine of beta, which is 45 degrees, minus sine of alpha, so sine of 30 degrees, times sine of beta, so sine of 45 degrees. And we can go and evaluate each of these guys and simplify. So let's see, cosine of 30 degrees, that's my smaller angle in the first quadrant, we get root 3 over 2. Cosine of 45 degrees, that's my middle angle, root 2 over 2. Minus sine of 30 degrees, that's going to be 1/2. And sine of 45 degrees is root 2 over 2. So you can refer to your unit circle to get all those values. And then let's finish simplifying. So first I'm going to multiply my fractions. For this first set, we'll get in the numerator root 3 times root 2, that's root 6. In the denominator, 2 times 2 is 4. For my second fraction, we'll get minus square root of 2 divided by 4. And then the last thing is we can combine our fractions. They already have the same denominator, so we'll end up with root 6 minus root 2, all divided by 4. And that's as far as we can simplify this one. Notice we can't combine our radicals because they're not like radicals. All right, let's look at another example. So example 2, we're going to find the exact value of sine of alpha plus beta, given that sine alpha is 1/5, and also alpha is in the first quadrant, and sine of beta is 2/7, and beta is in the second quadrant. So since we're asked to find the exact value of sine of alpha plus beta, that means we need to use the identity for sine of alpha plus beta, which you have a handout of all your identities, but let me just go back and look up that identity. Sine of alpha plus beta, that's this third one here. So we'll get sine alpha cosine beta plus cosine alpha sine beta. So sine alpha cosine beta plus cosine alpha sine beta. All right, and now our goal is to find this expression. So we're going to use the right-hand side. We have to find each of these 4 things in order to simplify and get our exact value. And we're given a couple of them. We're given what, let's see, sine of alpha is. So I'm going to go ahead and fill in the information that we know. Sine of alpha is equal to 1/5. So that's this entire expression, sine alpha. We don't know what cosine beta is. We're going to have to go and find that. Plus, we also don't know what cosine alpha is. We have to go and find that. But we are given what sine of beta is. Sine of beta is equal to 2/7. Okay, so what we need to do now is find cosine of alpha, cosine of beta, and then we can finish plugging in and simplifying. So let's start with, I'm going to start with cosine of alpha. So let's find cosine of alpha. And we actually have 2 ways we can do this. I'm going to demonstrate both methods, but in general, you can use whichever method you like better. So my first method is going to involve just drawing a right triangle. So here's my right triangle. Here is my angle alpha. And what information are we given about alpha? Well, we're told that sine of alpha is equal to 1/5. And remember, with the right triangle, here's my right triangle, definition of sine of alpha is opposite over hypotenuse. So that means my opposite side, that's this side here, is 1, and my hypotenuse should be 5. And in order to find cosine of alpha, that's what we're trying to do, well, I have to know what this bottom side or this adjacent side in my right triangle is. And so we can use the Pythagorean theorem. Let's see, we'll get x squared plus 1 squared equals 5 squared. So x squared plus 1 is equal to 25. That'll give us x squared is equal to 24. And if I take the square root of both sides, I'll end up with x equals plus or minus the square root of 24, which we can actually simplify this. In the radical, notice 24, I can write this as 4 times 6. Since 4 is a perfect square, I can take it out of the radical. And what I'll end up with is plus or minus 2 square root of 6. All right. And let's see. We want to find cosine of alpha, which, remember, cosine of alpha, that's going to be adjacent over hypotenuse. Now, another thing is x cannot be both positive and negative. We have to choose one of these signs. And because alpha is in the first quadrant, right, that was given to us, alpha is in quadrant 1, well, in the first quadrant, both sine and cosine are positive, right? This tells us that cosine of alpha has to be positive. So we're going to choose the positive value. So what we'll get here is cosine of alpha is equal to positive 2 square root of 6, right? Because this is x, this is my adjacent side, and then divided by my hypotenuse, which is 5. Cool, so there we go. We found cosine of alpha. Now I'm going to show you another method for finding the same value, which you might like more. And the other method is using the Pythagorean identity. Remember, the Pythagorean identity says sine squared alpha plus cosine squared alpha is equal to 1. And let's find cosine alpha from this identity. So let's see, sine squared alpha. Again, we're given sine of alpha, which is 1/5. So I know this first term here is 1/5 squared. That's what we mean by sine squared alpha. Plus cosine squared alpha is equal to 1. Now let's solve. Let's see, 1/5 squared is 1/25. Plus cosine squared alpha is equal to 1. If I subtract 1/25 from both sides, we'll get cosine squared alpha is equal to 1 minus 1/25. This is the same as 1 is the same as 25/25. And so then when I subtract 1/25 from that, we end up with 24/25. And of course I have to finish by taking the square root of both sides. So to finish solving for cosine alpha, I'll get plus or minus the square root of 24/25. But let's simplify this. And part of simplifying is deciding, do we use the positive or the negative sign? And again, because of this fact, because alpha is in the first quadrant, we know cosine should be positive. So we're going to choose that positive sign. Okay? And so we'll get positive square root of 24 over, square root of 24 over the square root of 25, right? Which we saw before, square root of 24, that's just going to become 2 radical 6. And in the denominator, square root of 25 is 5. Cool. So either way, we get that same value for cosine alpha. Right? All right. So far, what have we done? We figured out what this value here is. Cosine of alpha, we know, is 2 root 6 over 5. Cool. Now we just got to find cosine beta, and then we can finish simplifying the entire expression. So let's find cosine beta. And again, you can use either method. I'm gonna do the triangle method for this guy. So here's my beta, and we were told that sine of beta, what was sine of beta? Sine of beta is 2/7. Okay. So that means, again, sine is opposite over hypotenuse. So that means my opposite side, which is this guy, is 2. My hypotenuse is 7. And we again have to find x. So if we set up our Pythagorean theorem, x squared plus 2 squared equals 7 squared. So x squared plus 4 equals 49. We'll get x squared equals 45. If I take the square root of both sides, I'll get x equals plus or minus the square root of 45, which we can simplify. This is plus or minus. Notice there's a perfect square in here. 45 is the same as 9 times 5, 9 being our perfect square. So when we pull it out of the radical, we'll get 3 and then radical 5. But again, we have to decide, are we going to use the plus or the minus sign? And it all depends on what quadrant beta is in. And we were told that beta is in quadrant 2. So beta is in quadrant 2. And remember, our goal here is to find sine. Oh, we know sine, sorry. Our goal is to find cosine of beta. And let's see, since we are in the second quadrant, we know that cosine should be, cosine of beta should be negative, right? In the second quadrant, cosine, the x value, is negative. Okay, so that means we are going to use this negative sign. And we're going to construct cosine of beta, that's adjacent over hypotenuse. So what we'll get is negative 3 root 5 over our hypotenuse, which is 7. All right, now we have all of the pieces in our puzzle to simplify our entire expression. So going back again, this is our expression. Sine of alpha plus beta, this is what we're trying to find the exact value for, is equal to, let's see, what was this again? 1/5 times cosine beta. So 1/5 times cosine beta, which we found cosine beta, that's negative 3 root 5 over 7. What were my other terms? We had cosine alpha is 2 root 6 over 5, and then sine of beta is 2/7. So was that a minus or a plus? That was a plus. Plus 2 root 6 over 5, and this here was a 2/7. And now let's finish simplifying. So if I multiply these first two fractions, we'll get negative 3 root 5 over 5 times 7 is 35. Plus, if I multiply my second fractions, I'll get 4 square root of 6 divided by 35. And then last thing is, let's combine these fractions. We'll end up with negative 3 root 5 plus 4 radical 6 all over 35. And we cannot combine our numerator anymore because our radicals are not alike. So that would be our final answer. This is the exact value of sine of alpha plus beta. And there we go.